Okay. So the first topic for today is cloud formation. Thereafter, we move on to what Elastic Beanstalk is, and then to end with, we'll talk about the well-architected framework as outlined by AWS. Okay. The first topic for today is cloud formation. So, what is cloud formation? Traditionally, when we had to build a whole lot of infrastructure, you have to contact different kinds of vendors like Dell or probably HP, IBM, Cisco, Juniper, Hitachi for your SAN storage, or maybe NetApp, or different vendors to procure that hardware and build that infrastructure in your data center. Today, the way we provision the infrastructure has totally changed. Cloud formation is a language for you to describe what you want in the form of a file. And that language can be JSON, which is JavaScript object notation, or it could be YAML, which is yet another markup language. CloudFormation allows you to describe the components of your infrastructure in the form of a simple text file, and then use that text file to provision the infrastructure. And that means that that simple text file in the form of a JSON format or a YAML template can be used to automate and securely deploy the infrastructure in AWS. That single file serves as a source of your cloud deployment. CloudFormation is available at no charge, but you only pay for the resources that you will deploy in AWS. That's where your applications will be running. It's not about, or maybe not just about, deployment, but also redeployment. So you can safely deploy the resources in a repeatable manner. You can now build and rebuild your infrastructure and applications without having you to perform manual actions or write custom scripts. It's the cloud formation that takes care of determining the right operations to perform when managing your stack. And if there are any problems that cloud formation detects in your that single text file, it has the ability to roll back the entire infrastructure to what it was and show you the errors on the screen as to why it got rolled back. So now infrastructure is no longer in the form of a hardware, but it's in the form of a code, and hence it's also called as infrastructure as a code. So you are codifying your infrastructure, and that will allow you to treat your infrastructure in the form of just code. You author the code with just any code editor. It could be a simple notepad. Probably check it into a version control system, review the information, get your team members review that file as well before you deploy that file into production. AWS CloudFormation saves a lot of time and energy to deploy the infrastructure, and we can spend our time for better things. So CloudFormation is giving developers and system administrators the power to create and manage a collection of AWS related resources, provision them, update them in an orderly, predictable fashion. Amazon makes our life easy by providing bulk of sample templates in their repositories. Or you can create your own template as well. There are a lot of dependencies, runtime parameters that may be required to run your application, and you can define it in that simple file. You really do not have to figure out the order for provisioning AWS services. CloudFormation takes care of that for you. After the AWS resources are deployed, you can modify and update them in a controlled and predictable way in effect of applying version control in your AWS infrastructure. So you author the JSON or that yet another markup language file. One of the best features of CloudFormation today, in fact, right from the beginning, CloudFormation was introduced by Amazon, is that you now have a graphical user interface to just drag and drop the AWS resources into a blank slate, and it automatically builds that template for you. So we really do not have to learn a new language right from the scratch, but all you need to know is how to modify it. So CloudFormation gives you the ability to design your infrastructure visually, like how you used to do in Microsoft Visio traditionally. So there's something called as CloudFormation Designer, which is an equivalent of the GUI, the graphical user interface. Once you have designed the infrastructure or build the infrastructure in that designer, you can download that as a simple picture, JPG or a PNG file, and document that if that's required, or maybe send it to your peers for a peer review. These JSON files can be downloaded or saved to S3 bucket for future deployments or peer reviews. CloudFormation is one such tool which is supposed to be more done than said. So we'll quickly go to the CloudFormation interface in the browser. So let's see if I can open Firefox like that. There you go, aws.amazon.com. And I'll sign in. And in this, you will see CloudFormation somewhere under the management and governance. Now that you got just too many of these services, it's difficult to identify them. So let's make our life easy and quick by just searching for it in the search box. There you go. Create and manage resources with templates. Click on that and it takes us to that page. So right now I'm here in the CloudFormation page, and few of these resources have been rolled back. And whenever you see something like this, that means that this deployment has failed, right? It has failed. It rolled back for some reason, but we'll take a look at that. What I'm going to do now is quickly go to this little button called Create Stack and create one. You'll get multiple options. So AWS asks you, how do you want to create your stack? Do you want to create a stack from a blank slate with nothing in it? So it will then launch a graphical user interface where you can drag and drop the infrastructure. We'll take a look at that in a minute, but then let's go with the other ones. If you already have a template, maybe your colleague gave it to you, you can browse it as a file, or if it's there in the S3 bucket, you can just submit the URL of the S3 bucket here. Then this first radio button, which has default set of templates defined here. So let's say if you'd like to create a LAMP stack. LAMP stack is Linux, Apache, MySQL, PHP. So it will provision an instance with all of those resources inside that. And if your application needs Ruby on Rails, or if you want to create a WordPress blog, how about building a Windows Active Directory? All you got to do is click on that and then say next, next, next. It will create a Windows server with domain controller or Active Directory inside that. It just makes our life easy and quick. So time to market is getting considerably reduced here, right? These are the three options available if you already have the templates, but if you don't have anything, and if you want to start from a blank slate, we will then click on this button, which is Design Template. I just then clicked on it. It takes me to the designer, which will then give me three panes. One on the left side, there's one on the right side, and there's another one in the bottom. On the left hand side, you will see all the AWS resources that we have as on today. These are all the AWS resources that we saw right in here. Most of them, anything that CloudFormation supports, is inside this list. Of course, basic things like load balancers, VPCs, EC2s, S3 buckets. Well, those building blocks will of course be there in that drop in this left-hand side pane. For us to practice this, let's go ahead and build a small infrastructure instead of building big ones. Let's just think about something small. Let's go ahead and build a VPC. For us to build a VPC, building VPC. In fact, I was writing in a different one here, right here. Okay, building a VPC. So if you recall the steps to build a VPC, the first one was creating a VPC. Second step was creating subnets inside the VPC. The third step was to create internet gateway. I just put a short form here, internet gateway, and then attach it to the VPC, and then finally edit the routes to allow 0.0.0.0/0. Well, that's what we did, right? Let's go ahead and build this infrastructure. Okay, small one to start with, and then we'll definitely see what AWS has to offer. All right, so I'm back here, and because I want to build a VPC, I will scroll down till the point I see a VPC. Scroll down further down. It's alphabetical order, but then you will see that VPC is not there in this list. It is inside EC2 because it's part of the infrastructure. You will find it inside EC2. So expand that, and now try to identify VPC. If you look at these, there are network-related components that are there inside EC2, and then there you go, VPC. So I will hold my left mouse and then just drag and drop that all the way to this blank slate, and then leave my mouse like that. There are two things that you noticed. One is that you get this block as soon as you dropped it. Second is that it built a JSON automatically, right? Just some kind of a JSON, which is just certain grammar in it. And keep in mind that JSON and YAML are not grammar friendly. They're not grammar friendly at all. So punctuations, commas, curly brackets must be in the right places, quotations, and even it is case sensitive. So it cannot have things in lowercase if it's supposed to be uppercase, and vice versa. There's a beautiful button on the right hand side which converts the JSON to YAML. So we now know that that's how YAML looks like. Simple text. And what's more important here in YAML is the indentation. So what you see on the screen is not equal to this. See, it just gives you that error. So we have to be careful about indentations, careful about punctuations, commas, double quotes, single quotes. All that things are, uppercase and lowercase too. Okay. All right. So I got this message on the screen that says designer is out of date. Hit refresh. Now please do not hit the refresh on the keyboard, or F5 on the keyboard. There's a refresh button right here on the top right hand side. We have to hit that and it takes it over. Now When you are provisioning a VPC, we are supposed to assign a CIDR block, a classless interdomain routing block to the VPC in the form of class A, class B, or class C, one of them, 192 or something. So that's something we need to assign, and those properties go right inside this property curly brackets. So I have my mouse clicked right in between those two parentheses, curly braces, and then I make space for my property, which is a CIDR block, something like that. And then CIDR block can be something like this: 192.168.0.0. Well, while you're typing this, a lot of questions that come in the mind, like, is the C in uppercase, or I in uppercase, the whole thing in uppercase, or B in uppercase? Is it something like this? Or should that be in double quotes? Or should that be in single quotes? Should it be followed by equal sign or something like this? Should this be also, the property should also be in double quotes or single quotes? What is the right permutation here? Every time you see this, let's hit that refresh thing. What is the right way to write this? Is there a comma after this, or double quotes, or is it a semicolon or a colon? What is that, right? So the best way to learn this is by looking at the documentation. And I will not Google for the documentation because it's right here in this interface. So if you would like to see the documentation of VPC cloud formation, then you will right click on that entity. So when you right click, you get these four little icons or symbols. This is the eye, which shows me the properties like that. You can duplicate it by clicking on this button. This is the delete, and this last thing is the documentation. So as soon as you click on it, you will see that it has navigated to the VPC documentation of CloudFormation. So again, saving a lot of time. So now as you scroll down, it tells me that this is how it must be. The CIDR block must have C uppercase, B uppercase within double quotes, and then you define the string there. And this must also be in double quotes, by the way. If you look at the examples, it takes you right to the bottom. It says that this is how it must be. There are other properties of the VPC that can be defined, like enable DNS support, enable DNS hosting names, instance tenancy. Do you want this to be dedicated or default? What are the tags, key value pairs, right? So we can define things like that. And then if you scroll up, you will see the definition of each property. For example, what is instance tenancy and what are the values allowed, default or dedicated. That's it, right? These are the values allowed. Is this required? Do I really have to define it here? Well, I really do not have to define it here because it says that required property is no. There's only one property that is required, which is the CIDR block, and that is required yes. And this is the only attribute that a VPC needs for it to build itself. Other properties like enable DNS support, no, but it will accept values like Boolean in the form of true or false, not yes or no. Enable DNS host names, required. No, we really don't need that. But if you ever have to put it, you need a Boolean value like this, true or false, right? Okay, so I'll just pick up some of these non-default values. I'll copy them just like that and go back to this point and then place my mouse in the right places and then like that. Now whenever you see an X like this on the left hand side, it means that there's some problem. So there's an automatic JSON validation that happens. So this is live JSON validation. It tells me that there is a problem at line number 7. Always remember that once you have declared these properties like CIDR block, DNS support, and DNS host names, once you've declared, you do not need a comma. Just like in English, you do not put a comma at the end of the statement. Rather, you put a full stop or a period. But we don't even put that here. Just leave it, and then it makes it happy. All right. Now it still says there's some problem. I don't think so there's any problem there. All right, so how do we solve this? What I'm going to do is copy all of that. And then yesterday we went to one of these websites called as JSON validator, right? Okay. Let's see if it is really bad or validate. Okay, what's the problem? There is no comma here. There must be a comma, so I will fix it. There you go. As soon as you fix it, this goes away and it says designer is out of date, hit refresh. I always take this message as a good message, right? Do not hit refresh on the browser, but hit refresh here. All right. So now we have constructed our first VPC and learned how to add properties for this entity or a resource called VPC. Let's go to the other steps like adding subnets, internet gateways, and then attaching the internet gateway to the VPC. And I'll make some space here like that. I will play around. Okay, no problem. Okay, now I need to find where my subnet is and then drag and drop it in my VPC, and that's happy. And as always, CloudFormation is intelligent and it automatically made a JSON template and also a YAML template like that, right? So the properties are VPC ID and it has referred to a VPC. So here the reference is this guy, which is VPC 3KH. If you see that, it is 3KHBW and it has referred it to 3KHBW, which is good. So my subnet that will be created in this VPC. So it is attaching itself like that. There are other properties that I need to define like CIDR block. The CIDR block of my VPC is 192.168.0.0.16. So I'll be a little bit lazy here. I'll just copy that thing and click on my subnet to look at its code and then hit enter, paste it like that. And the CIDR block of my subnet, I'm going to put it as 192.168.30.0/24. We still have a problem here because after declaring every property, we need to have a comma, which we do not have. So I will put the comma at the place where my cursor is blinking like that. And it's happy. Now looks like there's a problem at line 10. And looks like the number of open braces is not equal to the number of closed braces. So I'll copy this, go back to my JSON validator without banging my head, and it says that there's a problem there. Let's see. So 1, 2, does it say something? Okay, curly brackets got an extra bracket there. Let's see. We'll get rid of this. Now is it happy? No. It doesn't need a comma. Actually, that's not the problem because this is the last property that's declared. We need to remove this comma and it's happy. So I'll go back, copy this and paste it there. And like I said, every time you see this message, it's a happy message. Click on refresh. That's it. You can, of course, declare other properties as well. For example, the availability zone in which this subnet needs to go. Well, right click, and if you look at the documentation of CloudFormation subnet, and then check the examples, it tells me that you can define a VPC inside it, define a CIDR block. You can also define an availability zone. Let's do it. We'll copy that and put a comma, paste it, and availability zone is also defined. And I do not need a comma after the last declaration, so I'll remove that comma. Now, another thing that needs to be noticed here is that this is being built in Virginia, which is US East 1A, but then this is Ohio, and Ohio is US East -2, so I will match it accordingly. I cannot have JSON or CloudFormation written in Ohio and let that built in get that constructed in Virginia. That cannot be done from here. Okay. Okay, so my first subnet is ready. VPC is ready. Let's make another subnet. And you know that it's not that difficult. You have to just drag and drop things. But then there's another lazier way I'm going to show you. All you got to do is right click, and then there's two little copy things, which is mapped to duplicate. Click on that, and then it creates another subnet. And now I have two subnets there, right? And I'll go back to my previous subnet, copy the content from here. That's what lazy admins do. Put a comma here, paste it, and this guy will go into B, and then make sure that my CIDR block is right, 192.168. This guy will go as 40.0 slash 24. Oh, how can it be slash 16? Slash 24. And this must also be slash 24. Okay, here you go. So going back, this is my VPC. Its CIDR block is 00/16. Subnet 1, which is 30/24. Subnet 2, which is 40/24. And this guy is going in 2B, and this guy is going in 2A. All right. Any questions so far? It does not copy the properties. It just copies the resource. So your question is, when we duplicated it, why it does not copy the properties? It does not do that. That's why it has been coded, because we may want to modify the properties. It's just there to make our life easier, not to spoon feed. So yeah, thank you. Okay, so moving on. Well, the next step is to create an internet gateway and attach it to the VPC. So I'll find internet gateway in this list, and it looks like it's alphabetically ordered. Scroll up slowly, and there's the internet gateway. Drag and drop always, and I'll just throw it somewhere outside the VPC. Now, the next step is to attach this internet gateway to the VPC, right? Did you notice this colorful dots? There's a blue dot, there's a purple dot for every resource. And if I just hover over each color or put my mouse on it, it tells me what it signifies. So this purple color for this internet gateway refers to depends on. This guy means VPC gateway attachment. What are the other things? If you put your mouse on each one of them, it's gonna tell you what it means, right? It's a VPC property. This is subnet network ACL association. So if you may want to put some NACLs here, that's when you will need this dot. Okay. So I was telling that if you need to add some NACLs to it, otherwise it will go and set up as a default NACL. You may want to just drag and drop this NACL where? Just anywhere. Okay. Define its properties. Define the NACL properties, and then how do you link it up? Something like this. Yeah. So then the properties that are defined in this NACL will be then linked to this subnet. Okay. That's why these dots are there. So I will delete this. I don't need that at this time. And what I need to do is just attach this internet gateway. And which one is the attachment? The purple one. And just hit my mouse, left click, and drag and drop all the way into my VPC and leave it there. That's it. So my first VPC is created. There's a lot many things that you can do inside this, like adding a route table, putting your own custom routes. Those are the things, and such things you have done already. But I was just showing how to modify things. What are the things that you should take care of when you modify this JSON? And if you click on these blocks individually, it's going to show that JSON code appropriately on each one of those segments, right? Just a minute, just 1 minute. Sorry about that. Okay, so the next thing what we have to look at is the full code. Here we were clicking on the individual components and then looking at this code, but how do I see the full-blown code here? Well, if I click on this little tab, which is called as a template, it will show you the JSON for all the resources that are there inside it. For example, you see the VPC JSON, the subnet JSON, the second subnet JSON, and then the VPC gateway attachment template. So you see the whole thing consolidated into one, and this is something we can keep for our references. You don't have to copy and paste this. You can always download this by clicking on this little button on the left side and then click on save. It will give you two options, whether you want to save it as a local file on your computer. You just give it a name, fab08, creating VPC, and save it, and it just goes and sits in your downloads, right? Another way to save it is by clicking on the Amazon S3 bucket thing and say, hey, create VPC. Just give any name, doesn't matter, but we follow the naming standards of your company. All right. Make sure that you make a note of this. Yeah, copy this and paste it. Okay. There are other buttons here like this, which will validate your template and see if there are any errors inside this. You can also undo. And there's this little button which says download. So you can download this as a PNG file. I'll just open it right now. It will open it as a PNG so that you can then send it to your peers for a peer review and then say, hey, this is what we did. This is what we want to accomplish. Things like that. It's a nice picture. Also goes well into your documentation. Okay. Then let's go ahead and build this. This little button which says create stack must be clicked on. So click on it. Make sure that you save your file. Save it, otherwise it's all gone. So now we are back to this screen which we were looking at earlier. Now we have the file on your local computer. It's there on the S3 as well. You can pick and choose just any option. I'll choose the S3 option, but it really doesn't matter. So I'll remove what's in there and copy this thing because this is where my VPC is. Paste it and say next. Give your stack name, say create VPC or something. Next. Key value pair, any permissions that you want to grant. Do you want things to roll back if there are any problems? And there are advanced options as well. Do you want to get notified once this is completely built? Do you want to protect against termination, timeout, rollback on failure, yes or no? But by default, there is a rollback on failure. But if you don't want to do that, then you say no. I've seen most of the times we keep it as yes, because if we say no, and if there are 10 resources that must be created, there's a problem at the 9th step. It's going to build all the 8 resources and then leave things from there on. So that way your meal will be just half cooked, right? You don't want that. So I'll say next here, this is a summary, and then just create. Refresh it. There you go. This is our stack that we just created. The creation is in progress. What we can do now is let's look at the logs. So click on create VPC, and then if I have the events tab is right there. And then I'll keep on refreshing this. Yeah, it's doing something. The VPC creation is complete. Internet gateway creation is complete. Refresh that. Still busy. Oh, while that is doing, you can look at the code as well, which is the whole JSON thing, which is there inside the template, which you saw a few minutes ago. And the parameters that have been defined, like key value pairs, it's all seen there, including the tags. Right. This is done, almost done. Creation is complete. So we did everything in a right way. Now let's go to the VPC section and actually see if the VPC is built. So let's go to services and VPC. Here you go, I've got two. I had just one, but now I got two. Let's see. Yeah, so this is my new VPC that got created. 192.168.0.0.16. Look at tags. If you look at the tags, it's easy to identify whether it was created manually or through CloudFormation. And just by looking at these key value pairs, it is evident that it was created with CloudFormation. How about subnets? Of course, you'll have everything in there. We got two subnets, and the tags will tell that they were created with CloudFormation. This is 192.168.30 and then 40. That's exactly what we punched in the JSON as well. Internet gateways, I must have two of them attached to our VPC. There you go. So we were successfully able to build a small infrastructure with CloudFormation. But remember that we build infrastructure in AWS using CloudFormation. And then what we build is something that's repeatable. You don't build things like VPC. I just picked up this proof of concept because it's easy, it's quick to do, and there's not many intricacies involved in it. But if things needs to be rebuilt again and again from the scratch, for example, a load balancer, a couple of virtual machines, and you also want to build an auto scaling set along with it with the properties defined inside that, and then you want to put a WAF in front of it with the rules that you may want to specify to protect it against DOS and DDoS. Well, that's the whole infrastructure that needs to be built. That's a good candidate for for writing a JSON, investing your time in building stuff like this in CloudFormation. So that is not a daunting task because Amazon has made our life easy. Like I was saying, they have a whole lot of repositories inside this, which they call it as sample templates. So if I click on this, it will take me to another section in AWS where you can look at sample templates, template snippets, and the documentation specific to CloudFormation. Let's look at sample templates here. So you can build an auto scaling stack, and it tells you, or maybe asks you, what do you want to build? Do you want to go for an auto scaling group with scaling policies that are based on CPU usage, or this, or this? Do you want to create a batch environment, a config environment? So as you scroll down, different permutation combinations of infrastructures are available right here. You can pick and choose based on your requirement or nearest requirement, modify it, customize it as per what the business needs, and there you go. You just save it there. That's all. This is creating a VPC and adds an EC2 instance with an Elastic IP. You may want to explore some of this to get a better handle on CloudFormation stack. Let's just look at it quickly. So I'll pick up just anything randomly. Let's say load balancer creates a ELB and an auto scaling group. So do you want to just look at the code? So I will open in a new tab, and it shows you that this is what it is doing, right? Hundreds of lines of JSON. Or if you want to view in this just the designer. So if you click on that, it takes me to the CloudFormation in my subscription and opens up this little JSON that they built, but in the form of a picture, something that's more appealing to the eye. All right, so here the components that are there are like this. They are building an ALB target group. So if you have built a load balancer, you know that these properties, the port number on which the load balancer is listening on, the healthy and unhealthy threshold count, application load balancer. Looks like they're building an application load balancer. These are the launch config properties. referencing an instance type, the security group on which it is open, so it is referring to another section here. Auto scaling properties have been defined: min size, max size. Security group is being referred, so you've defined port number 80. What port is it listening on? 80 here, HTTP. So this is a very basic template. There's always a scope to modify a lot because we see that in production environments they do not have port number 80. You got 443, which the load balancer will be listening on, and then internally on load balancers on the EC2 instances you'll have 80. The HTTPS certificate is terminated on the load balancer. Internal traffic is going on port number 80. So there's a lot of scope for modifying this to fit into our business use case to make it more secure, but good percent of the job is done here. It's a good more than 50% of the job is done. All you gotta do is drag and drop few things from here, save it, and then do a peer review, make sure that it is following the security guidelines, and then deploy it. And the first thing you do is deploy in development, run through certain vulnerability assessment tools to see if there are any vulnerabilities in this infrastructure at the network level, at the application and the operating system level. Any vulnerabilities found are then fixed, and then it goes to a second peer review and then goes to prod. This is a process that I define. The process always varies from one company to another company. But yes, there are certain standards as well that the security team sets. And any questions on this part so far? No? Does that give you confidence that you can build your infrastructure with code? Yeah. Yeah, just one more thing, that if I go ahead and delete this, right? If I say actions and delete stack, yes, delete, my infrastructure is also going along with it, right? So what are the events? It will go ahead and start deleting my gateways, attachment that's done with subnets, VPC, everything that you built will be cleaned up. So if you ever want to clean up your resources that's being built with AWS Cloud Formation, you just have to delete the stack. Yeah, so this will be gone in some time. There you go, it's gone. It's actually gone. I will have just one subnet now, and probably one gateway, and earlier we had two, right? Okay, so if you have no questions, then we'll just take a quick 10 minutes break, and then we'll come back and do the next topic, which is Elastic Beanstalk. Okay, gentlemen, let's get started with the next topic, which is Elastic Beanstalk. Hopefully everybody's ready. Looks like there are certain applications already built here, so I'm not going to disturb this. I'll go to a different region, probably Singapore or something. Okay, so we're moving on to another subject here, which is Elastic Beanstalk. Um, Elastic Beanstalk is another service offering from AWS or Amazon that will let you build infrastructure, and we really do not have to focus on building the infrastructure in this case, but you have to focus on writing a better code. Now this tool is more from the developer side. This is going from the developer side, um, and very less part of it from the infrastructure side of AWS. With Elastic Beanstalk, you can deploy and manage applications in AWS without without you worrying about the infrastructure. So the developers have to spend more time on writing a better code, and that code could be on several well-known platforms that we have today. For example, .NET, Python, Node.js, or probably Ruby, PHP, etc. There's several well-known platforms that Elastic Beanstalk accepts as on today. So developer has to just go ahead and write his code and then zip it into a zip format with the .zip extension, and then just throw this zip file onto Elastic Beanstalk. What Elastic Beanstalk does is that it builds the infrastructure automatically. For example, it builds the EC2 instances that will be used for hosting this code. It also can build a load balancer, can also have the auto scaling setup. So it will take care of the end-to-end hosting part of the code that the developer has written. Once the infrastructure is built, it's then the responsibility of the infrastructure team to take care of the patching and whatever things are required. Yeah, patching, updating, managing, adding additional disks, monitoring, installing the antivirus, etc. All that things can be done or should be done from the infrastructure side of IT. Let's go ahead and see what the Beanstalk has to offer. Let's go and do certain lab practice here. And make sure that you read some of this text here, scroll down, and then see what kind of platforms are accepted as on today. But I'll click on Get Started. So this is letting me create a web application. I'll give it a name, for example, vendor app or something. And I need to pick and choose what platform my code is written on. Is it on Docker or Go or Java or Ruby? So you can just pick and choose one of them. So let's say my application is built on PHP. Most of the web platforms are either built on PHP, HTML, or .NET. And if you have your application ready, you have to zip it up and then upload it in the form of a zip file or a WAR file. I'll click on sample application because I don't have any code. So Amazon has a sample code with them, and that will then be uploaded to your S3 bucket. So as soon as I click on create application, it will upload that to an S3 bucket and then launch the application from there. There is another button called as configure more options, which will let me choose the kind of instance or the instance type, the key pair, the VPC in which it must be deployed, the size of the hard disk, whether that should be encrypted or not, the cloud formation, or the cloud watch options, the disk size, what kind of a disk is that, general purpose or provision IOPS, load balancer, do you want that to be application based load balancer or network based load balancer? What are the parameters of the load balancer? How about auto scaling? What is the min and max values of the auto scaling? Well, those are the things that it will let you choose in detail if you click on configure more options. But if you just ignore it and click on create application, it will pick up the default values. However, most of these attributes can be modified later on as well once the application is built. There are few items that cannot be modified, and they are the VPCs and subnets. They cannot be moved once the application is built on a VPC and a subnet is picked up. There are several other attributes that can be modified. So let's click on this create application. It will take some time to build this because it has to create an EC2 instance and the whole app must be healthy and ready. While that is being built, we have to just look at these lines of logs that will be written as and when a resource is published and provisioned in AWS. Is creating an environment, the first thing that's going to do is copy the code into an S3 bucket, then create a security group, create an instance, etc. So we're just waiting here. Okay, looks like there's some action here. And we can scroll down and see what it did. So it created a stack, but it failed. Resource creation cancelled. There are no instances, and it's all pending. So here we have a error which says that there is no default VPC for this user. And that's why it all failed, and it's never gonna pass through this. It will just sit here as long as we sit in front of it. It's not gonna go past through it because there is no default VPC. So there are two ways we can solve this. One is go to a different region where we have a default VPC, or go through an advanced setup where you pick up a VPC for this region and then deploy it there. We can pick and choose any of those options. In this case, I'll choose the second option. Um, so I'll clean this up first and then create a new app. Where's the delete button? About yeah, terminate. Okay, so we'll just wait for this to get terminated and then we'll build a new instance. Like I said, there are two ways. The reason why we got this error is because this region does not have a default VPC, and that was clearly showing there. Okay, I'll delete the app. I will be back to ground zero. Get started. Give application a name. New platform. Just select anything. Sample application. Now if I click on create application, I'll bump up to the same error message. So I would like to configure more options. So the options that we have here are as follows. Software, instances, these are just the categories of options that you have. So the place where I can change the VPC is the network. So you can modify it in the drop down menu. You can select your VPC. None of these are my default VPCs. So looks like the default VPC got deleted. So select that and then click on subnets in which you would like to have your application deployed. And if you would like to have a public IP address to the EC2 instances in your environment, well, that's just only for static IP addresses, which is okay. Save, and rest of the options I will just leave it as default for now, because later on we'll be revisiting these options later again to see what they are, as to how to customize these things once the application is built. We'll just pause for a minute. While we're waiting for this, please feel free to ask questions. Could be related to this or unrelated. Could be exam or anything else on AWS.
So question is, do you have any PDF to pass this exam?
PDF like which PDF? There's no shortcut, I would
Uh,
say.
no, no shortcut question answer where we can read. I mean, I don't think so. But yeah, just wanted to know.
Well, there are lots of. I know you're looking for dumps, but there are a lot of dumps available out there on the internet, from Viz Labs and things like that. So you may find there. But then Amazon keeps on changing these patterns and exam questions and keeps on rotating them. Because I discussed with my previous colleagues who are still attempting the exam one after another, cracking exam one after. There are like 7 or 8 exams now in AWS. When I attempted like few years ago, and now the pattern has totally changed, and I find myself lucky that it was kind of easier at that time. I'm not saying that it is tough. It's just that we have more resources and more radio buttons and check boxes to look at here.
So is there any
That's
official
helpful.
study guide for this advanced architecture course, so that we can go through that and prepare for the exam, or just have to read everything at the AWS?
So what we are going through in this session is the advanced architecture. As if you just do the labs and if you understand now, advanced architecture is nothing but the professional exam, right? So if you just do all these labs and understand the nitty-gritties and the architectures involved in it, I don't think you even need a book. And then I haven't seen anything that's related to professional AWS solutions architect professional book. But yeah, I have the book related to associate, official study guide, associate. Yeah, so they're
Yeah,
all.
everything I see is for associate, so but not for the
Yeah, somebody may. Oh, this guy Zilvora. He has good videos on as well on Udemy, but it's not available. Okay, very good. Zilvora, he has videos on Udemy and other platforms. Okay, so there isn't one. Going back to this section, looks like this is green and healthy, so it's all happy here. How do I access my applications? If I click on this URL, just click on it, and it tells that hey, your web application is ready. So this web application is being pulled from an S3 bucket, and certain content is there in the EC2 instances as well. So if I go to my EC2 instance, I will see that there is an EC2 instance built on my VPC, which is hosting this web app, right? So this is picked up from where? CloudFormation Stack, like Elastic Beanstalk. Yeah, so that's the application. It did not take much time, but the EC2 instance was launched. Is it T2 micro or T1 micro? What is it? It looks like it is T2 micro. What if you ever would like to change it? Remember that the developers won't have access to this console. They will have access to just the Beanstalk because they will be deploying with the IAM credentials that you have given to them. So if they ever have to change certain things, for example, changing the instance type or then changing the Elastic IP to something else, adding additional disks and volumes with encrypted state, connecting this with relational databases, encrypting that. So all those things are available under the configuration section in the Elastic Beanstalk. These are individual blocks which can be modified, and the developer can do it all by himself. So just pick up this one, instances. So click on modify. Instance type can be changed to whatever you want. But again, this is not on the fly. This does not happen on the fly. I'll just show this to you. So if I go to, I'll just select M1, M1 medium or something, just M1 small, okay. If you would like to change an AMI ID, monitoring interval, root disk volume, size of the disk, IOPS, all that can be modified, and then just say apply. And then you'll get a message here which says it's a warning. And this warning says that for these changes to take effect, the machine will get restarted. So this definitely needs downtime. So my virtual machines that are hosting my application will shut down, and a new instance will then get created with a new instance type. So there are certain settings that needs the machine shut down and downtime, and there are certain settings that do not need it. So you should be cautious about such changes that needs downtime, so hence it cannot be done in production. So I've just clicked apply to see if it actually reflects here. Upon hitting refresh, I must see that it just shuts down and maybe builds a new one. Let's see. You may also want to monitor the logs closely to see what's going on. And there's another place where you can look at the logs in detail. Well, these are the logs that can be requested. So request last 100 lines or full logs. Keep in mind that it will give you the application level detailed logs. Error occurred. So two operations cannot be done at the same time. So the environment must be in healthy state, and there must not be any changes happening in the environments for you to pull up these logs. Just waiting for this. So as you see, the instance was shut down from Beanstalk, and a new instance is being built up. The instance type is changed from T2 micro to M1 small. And such changes will definitely need a downtime. So if I click on this parallelly, would I be able to access my app? No. So my application is shut down at this time. See? It's not working. And it's not going to work because the server itself is down. So once it is up and running with the public IP and all those parameters, you will then have the application connected back. So under configuration, you can not only modify the instance related thing, but you can change it to a load balancer based environment, change the capacity from single instance to a load balanced environment. You can also change the auto scaling options like this: minimum, maximum availability, the cooldown period, the scaling triggers. When do you want the auto scaling to trigger? Do you want the auto scaling to trigger based on network or CPU or disk IOPS? Latency is too many options there. So I can select that CPU utilization. So when the average CPU utilization is greater than, let's say, 60%, yeah. So when the average CPU utilization is greater than 60%, I'm putting the unit as a percent there, for approximately 5 minutes, what do you want to do? You want to increment one instance. And similarly, I can just say if the CPU utilization is less than 30%, do a -1. That means the instance gets terminated automatically. So this is going in conjunction with load balanced environment and auto scaling, which can be defined right there. You can also define time based scaling and say that I want my auto scaling to happen at the time when my sale period starts at 7 o'clock. So a scheduled action can be defined here. So auto scaling will be automatically triggered, or new instances are automatically triggered at the following time defined here. Do you want it to happen just one time or on recurring basis every day? So these are pretty neat things that AWS has in the Beanstalk. Security, do you want to modify your key pair? How do you log into this machine? You cannot log into this machine because this guy doesn't even have a key pair. Yeah, key pair name is not defined. So I can go to this point and then select your key pair. So just select one of them and then apply. This is applies grayed out, probably because my environment is okay. Employment is okay. The environment is all right. So go back to configuration and redo that stuff. Let's see, modify. Yeah, that's good. Yeah. So again, such kind of configuration needs a restart. Changes to EC2 key name. This is another option which will need a downtime, right? And your EC2 instances are replaced. The other things like when and how do you want the updates to happen, changing of public IP addresses, monitoring you need to enable, connecting it to a database, notifying to an email address to a particular SNS topic or an email address. So this is basically the dashboard of a developer to modify the infrastructure. It really doesn't have to know complex things in the architecture of the infrastructure. You just need to know how to play around this little tool, which is Beanstalk. Let's go back and see if my website is up and running. There you go, it's up. The health can be monitored as well, and it gives you how many 200 or 2x messages or 404, 405, 303 messages that people are getting on the web app. It gives you an overall idea as to how many instances are actually hosting the web application. Monitoring, this is also pretty good, gives you the CPU utilization or an average CPU utilization of all the resources you have in Beanstalk. Maximum. So this is more of a dashboard. People like to keep it on their screens to see the performance utilization, CPU utilization. Again, you can get alerts as well. There's a little bell icon on the top right hand side of every graph. Once you click on it, right, it's gonna take you to the alarm section. So this is alarm section. Why don't I see it? Let's go back. Monitoring. Click on this little bell. Yeah, and then you can say that CPU utilization is high for a period of 1 minute. So every time a CPU utilization is greater than, let's say, a number called 60 for about a minute, you will get notified. Any person who is mapped to this notification will get notified. So you are just looking at Elastic Beanstalk as an easy tool for the developer to deploy and manage the infrastructure, where he doesn't have to go through multiple interfaces to manage the infra. It's just one-stop shop to build, manage, get alerted, alarms can be set up, manage the updates as well as to when they want the updates to be happening on their infra. And this is from the events side, where a developer will know all the events that have happened since the birth of Beanstalk environment, or his particular environment. Everything and all the changes that have happened so far will be written to this event log. And tagging is no different. It's just like the tagging that we learned yesterday, um, to manage your resources in a better fashion. On the top right hand side, you have this actions button, which will let you load a configuration. So if you would ever like to uh, update your new code, you can go here, upload, and browse to your WAR file or a zip file, and then your application gets the new code. You can save the configuration, swap environment URLs, clone the environment, which is a great option. Most of the changes developers do They're actually done on the development environment and not on prod environment. So what people usually do is they do not touch the prod environment. They will just clone the existing environment and make any sort of changes that the customer has requested for on this cloned environment. And I'm actually cloning it right now so we can see. So I will have two applications now running parallelly. One is a prod app and second is a dev, kind of a dev app. There you go. So one is prod, this is the first one that we built, and the second one is a dev app. And both of them have a similar URL. At this time, site cannot be found because it's too early to click on. It's still building it. It is copying the code and building the whole environment. If I click on refresh, I must have few more instances in some time though. Let's just give it some time. So I'm cloning that entire environment. So you may have a whole stack of infrastructure like a load balancer, a couple of virtual machines, and auto scaling. So your Elastic Beanstalk environment gets copied along with its settings, which is great. Now, if I as a developer ever would like to modify things on prod, I will not do that. I will first do it on test, which is this clone environment, right? And once I've done all the testing on my test environment and my customer is happy that this test environment is great and ready to go live in production, this guy works really good, and this production app doesn't look as good as the test environment because the test environment has the new code, has the new binary, has new pictures and new videos that the customer always wanted. He visualized his website or the project to be the one that looks in the test environment and not in prod. So now he would like his customers to be redirected to the test environment and not to prod. And that can be simply done using this option called swap URLs. Okay, action and swap environment URL. So if I click on it, you need at least two web environments. And this error message makes sense because my second environment is not ready yet. So let's just watch for this to complete. Okay, it's still being built. We just have to wait for this thing to finish before we can proceed with the next labs. Any questions, guys? Okay, so I'll go
Is there any setting that would allow you to fork the um, the transactions? So if you're in your development environment, you could actually continue to process your production traffic, but you could also redirect some of that into the dev environment for performance testing.
Yeah. So we are now talking about um, managing the traffic. Let's say you want to send 80% of the traffic to the prod, and you don't want to do a big bang deployment of the new test environment. So you'll just say 80% goes to the prod and 20% goes to the test environment. That's what you want to do, right?
Yeah, well, that's one thing. The other is 100% to prod, but then take 20% of those transactions and read and fork those, so it goes into both the prod and the dev. Is that possible?
Oh, we need to use Route 53 for that. So if I go to Route 53 and then use traffic policies, in the traffic policies, I will define these URLs. I'll pick up this URL, which is the prod URL, and then go back to this test environment, pick up its URL as well. Go here and define the traffic policies there, like this. So I'll say policy 1 underscore Beanstalk, something like that, and say next. And I'm gonna say weighted rule. I'm saying that 90% of the traffic goes to my new endpoint, which is Beanstalk environment, and which ones are they? Maybe new vendor app is my prod, and I don't want to do a big bang deployment, so the 10% goes to this guy, which is Beanstalk, and that. So I'm distributing the load across multiple platforms. So if there are any bugs or complaints from my customers, it's just the 10% who complain, and slowly as we mature and start fixing things, we can increase this number and reduce this number. We can also map it to a sub component of a web application as long as it has a URL. So you can just go and define those URLs here by selecting the empty value attribute. If you have the URL for that app, I'll go here and put that URL like that, whatever URL it is. Does that answer your question?
Yes, it does. Thanks.
Thank you. So looks like my environments are ready. This is my production app and all my customers are hitting here. This is my dev app, and this has just been accessed by my customer and the developers who are testing it. And now it's time to swap them. But before swapping them, we should also do this kind of testing, because if there are any bugs, then your customers will really be annoyed. So we do testing with Route 53, where you send partial traffic to your new Beanstalk environment. And once we have some situation like this, where 10% is going to your old app and 90% is going to test, now we are ready to swap the URLs. Just swap the URLs and say anybody who's going to env now goes to env1. Just swap it, right? And it really doesn't need a downtime. It is pretty quick. There's no downtime. It works. There's no 404, no 303. This is quick. And so now test becomes prod and prod becomes test. You can restart application servers and rebuild it and terminate them. So Beanstalk is making life so easy for the developers and also for the infrastructure team, because that means there are less incidents to handle. Because the infrastructure guys are doing a lot of things by themselves, and there are less incidents to handle. Yeah, we have to patch it. That doesn't mean that we are losing our jobs, but we have to patch it. We have to maintain it. A configuration management must be created by us. Vulnerability testing, penetration testing, this is all done by us. Managing the ports, security groups is done by us. Anything on the route configuration is done by us. Taking snapshots, backups, or archival, managing the data in your S3 buckets, it's all done by us. Just that developers have a self-service provisioning portal and a tool for an end-to-end deployment of the infrastructure. Any questions on this one, please?
So real world practice, do you see a lot of this where a developer would deploy a secondary stack, route 10, 20% of the traffic to it, and then gradually increase that, and then once they've And then when they're fully migrated, they just blow away the old environment?
Yeah, they do.
Or they,
They
okay.
they do it from AWS, but they will still keep the code in their version control environment for historical analysis. They just don't delete it, because if they ever have to refer to it, they will have some kind of a code to look at. But it's important that we go ahead and delete the infrastructure from here, because you're still paying Amazon for these resources, instances, and all the traffic that gets in there. So yeah, we'll definitely blow it up from AWS.
Okay.
Yeah. So I will clean up the environments one by one, terminate it. Okay. Actions, terminate, and that. Any other questions, please? Okay. So the deletion has been initiated, so it will get deleted anyway. So I'll get rid of these things and leave page. Yeah. Okay. Okay. So let's look at the next section for today, which is cloud or AWS well-architected framework. Just looking at the source of the noise. There's some background noise that I hear. Um, so it will be great if we mute it. Thank you very much. Okay, so we are talking about the next topic after CloudFormation and Elastic Beanstalk is the well-architected framework that AWS has designed. And this actually helps us understand the pros and cons of making well-informed decisions while building environments in AWS. By using this framework, you will learn the best practices for designing and operating reliable, secure, efficient, cost-effective systems in the cloud. The well-architected framework provides you a way for you to consistently measure your architectures against a set of best practices and identify areas for improvement. The set of processes which you'll have for further reviewing of your architecture in a constructive conversation that you can have with architectural decisions, but it is not an audit mechanism. Okay, the last word, it is a framework. That means it's just a skeleton. There's always a scope to add more value to it, customize it as per your requirements. As on today, there are 5 pillars of the well architected framework: security, reliability, performance efficiency, cost optimization, and operational excellence. So in this discussion today, we will walk through each of those pillars of architecture and understand what what is the AWS point of view in deploying your infrastructure in a secure, reliable, and efficient way, at the same time cutting down on the costs. Security. There are multiple layers of defense that the infrastructure must have, even on premise. This particular pillar focuses on the security aspect of your infrastructure and then how it applies to different situations and how it gives you different solutions to those situations. Ensuring security can be challenging in traditional on-premise solutions due to the use of manual processes, different security models, and there is insufficient auditing. By adapting to the processes in this security design, you can build architectures that protect data and systems, control the access, and proactively respond automatically to security events. This is a focus area for chief technology officers, architects, developers, team members, everybody. The security pillar says that we must apply security at all layers of your infrastructure, provide defense in depth mechanism, enable traceability, implement a principle of least privilege, focus on securing your system, automate security best practices. So it's paramount that you implement the principle of least privilege and enforce separation of duties with appropriate authorization from your AWS resources, centralize the privilege management and reduce or even eliminate reliance on long-term credentials. You will enable the traceability using CloudWatch monitoring, get yourself alerted with simple notification services, audit with CloudTrail. When any changes to your environment in real time must be notified, so that way you integrate with your logs and metrics with systems to automatically respond and take action. Applying security at all layers is part of the defense in depth approach with the technical control mechanism, and you apply it all layers. It could be on the edge network, on the VPC, at the subnet level, at the load balancer level, every EC2 instance, and then you get into the host level, then have the security at the operating system level by performing security hardening procedures, and then security at the application level using application security or application hardening procedures. Protecting your data at rest and transit is something we spoke about, and the methodologies that you will use is by using encryption, tokenization, and access controls wherever appropriate and wherever possible. Identity and access management is a key. Who should have access to your data? And then if they have access to your data, to what level should they have it? It's also important to classify your data based on the risk it has. Is it high risk, low risk, medium risk, or we don't care about it at all? So based on that, you may want to grant access or you may want to grant restricted access. Basically, you want to just keep people away from the data. So for that, you will have mechanisms and tools to reduce or eliminate the need for direct access or manual processing of your data. This will directly reduce the risk of loss or modification and human errors when handling sensitive data. You also prepare for security events. prepare for an incident by having an incident management process that aligns to your organization requirements. Run the incident response simulation and use tools which will automate to increase your speed of detection, investigation, and recovery. These are the 5 important points under security: IAM, detective controls, infrastructure protection, data protection, and incident response. In AWS and in every cloud provider, um, there's a concept called as shared responsibility model, and that shared responsibility model tells us who should patch, what is Amazon responsible for, and what is the cloud provider responsible for. So the AWS shared responsibility model enables the organizations that adopt the cloud to achieve their security and compliance goals. It's the AWS responsibility to physically secure the infrastructure, physically secure the cloud services. And as an AWS customer, you and I can focus on just using those services to accomplish your goals. Identity and access management. So we're just going through these bullet points one by one. IAM. Identity and access management is a key or the heart of information security program, ensuring that authorized and authenticated users are able to access your resources only in a manner that you intend. You should define users, groups, roles, policies, and what kind of action they take in your subscription must be clearly defined. So you chalk out the policies and align those policies with the principles. When I say principles, it is the users and objects. Is it clear so far? Any questions on this one? Okay. In AWS, there are number of different approaches to consider when addressing IAM. You will protect your AWS credentials, and also you will have fine-grained authorization. The careful management of access credentials is the foundation of how you will secure your resources. Every interaction that you make with AWS will be authenticated. So establishing appropriate credential management practices and patterns allows you to tie the use of AWS to your workforce lifecycle and ensures that only the appropriate parties take action in your account. When you open your AWS account, the identity you begin with has access to all the services, has access to all the resources, and that account is called as the root account. You can use this root account to establish or create less privileged users and create role-based access in AWS IAM. However, this initial account, which is also root account, is not supposed to be used for everyday activities. And these credentials must be carefully protected with multi-factor authentication. And also, the keys, the secret keys and the access keys mapped to this root account must be deleted after completion of the initial account setup. The root user, you must follow the best practice of only using this login to create another set of IAM users or set of groups for long-term identity management operations. And then these users are carefully monitored and constrained and can be used to assume roles in one or many subscriptions. You will choose to establish trust with existing identities in your office, in your premise, in your data centers with recognized protocols like SAML or any web identities. Federation will reduce the need to create users in IAM, and you can leverage the existing identities in your directory services, existing credentials, and role-based access you might already have established in your organization. And then you will have appropriate password policies set up following the rules of the password game with minimum length, complexity requirements. And it's also paramount that you have a mandatory rotation policy requiring IAM users to change their passwords at regular intervals of time. For all IAM users with passwords permitting access to AWS Management Console, you should also require the use of MFA. That's the various mechanisms how you protect your credentials in IAM. Fine-grained authorization is about establishing a principle of least privilege that ensures that authenticating identities are only permitted to perform the minimal set of functions necessary to fulfill a specific task while balancing usability and efficiency. Your organization should define roles and responsibilities for users and applications. Fine-grained authorization is implemented in AWS using IAM roles and policies. A role is an IAM principle assumed by a user or another AWS service. In parallel, you will have to capture and analyze the logs using CloudTrail logs or using CloudWatch logs or other endpoints to monitor the user activity as well as the API activities globally. There's a service called as Guard Duty that is used for threat detection that continuously monitors for malicious or unauthorized behavior to help you protect your AWS accounts and workloads. AWS Config provides you with an AWS resource inventory. So config is more like a CMDB tool that will tell you the configuration history, configuration change notifications to enable security and governance. The logs are kept in S3 or probably in Glacier, monitored with CloudWatch. There are detective controls, and these are the controls that AWS has to detect, like I was saying, AWS config, CloudWatch, EMR, which is for Elastic MapReduce, S3 in Glacier. You integrate auditing controls with notifications and workflow. Detection of services, detection of specifically the data that is flowing in and out of your AWS infrastructure to identify a potential security threat or incident is done with the help of the services that are listed there. And that is essential part of the governance framework, can be used to support a quality process, legal or a compliance obligation. We know about config now, and EMR actually stands for Elastic MapReduce, which is equivalent to Hadoop and big data services or Spark services, which can handle massive amounts of data that can scale across multiple EC2 instances. So EMR is used to keep the logs in there because it has the capability to analyze massive sets of data in very, very short periods of time. Infrastructure protection. The first part was detection aspect, and second part is the protection aspect. The protection is about encompassing the control methodology such as such as defense in depth necessary to meet the best practices and organizational or regulatory obligations. Infrastructure protection is key part of information security program, and that involves trusted boundaries like network boundaries, packet filtering, hardening procedures, patching procedures, authentication and authorization procedures like managing the users, keys, and access levels, and also enforcement of service level or service level protection like using WAF, web application firewalls, or API gateways. So protecting the network and host level boundaries is done at the VPC level. So you protect the infrastructure at a VPC, subnet, routing tables, NACLs, gateways, security groups to achieve the network routing as well as the host level protection. Is there any question someone has? If not, please mute. Thank you. Moving on to the next section, where we are also interested in maintaining and the careful management of your security configuration of your systems running within the environment will help us build a robust, scalable system. The security posture of your systems is a function of the controls that are available and your own controls such as operating system, installed threat detection, vulnerability scanners, anti-malware detection. AWS Systems Manager, Inspector, Bastion Host, State Manager, Inventory, and Patch Manager are some of these service offerings that AWS gives to patch and manage your infrastructure and do certain automation there. AWS Inspector can be used to identify the vulnerabilities or deviations from the best practices in your guest operating system and applications. There are other tools like a run command used to execute a batch set of commands to hundreds of machines at the same time. State Manager will tell us, compare it with the baseline of your operating systems. Inventory pulls up or collects and queries the configuration of your instances and the installed software. And Patch Manager is a patching tool that will help you deploy operating system and software patches automatically across large groups of instances. Data protection. Before architecting any system, foundational practices that influence security should be in place. For example, data classification provides a way to categorize the organization's data based on the levels of sensitivity, based on the encryption of data. And these methods are important because they support objectives such as preventing financial loss or complying with regulatory obligations. There are a number of different approaches to consider when addressing data protection. And these, the list that we see here are the approaches like data classification, encryption, tokenization, protecting data at rest, protecting data in transit, data backup, replication, and recovery. What is data classification? Is there any question someone has to ask? If not, please mute yourself. This is a background noise that will get into the recording. Data classification here provides a way to categorize your data based on the sensitivity, like I said, based on the location where the data is located, based on access levels. By carefully managing an appropriate data classification system, you can map the controls and level of access protection which is appropriate to the data. For example, a public-facing content is available for anyone to access, whereas important content is encrypted and stored in a protected manner that requires authorized access to a key for decrypting the content. And we use various features given by AWS like resource tags to tag the data classification. You can use IAM policies, KMS to encrypt, hardware security modules to provision and keep your keys, and you can define and implement your policies for data classification. For example, you can have S3 bucket that contain highly critical data or EC2 instances that process confidential data. They will be then tagged with critical classification. You can define these access levels in KMS encryption keys. Encryption and tokenization are two important but totally distinct data protection schemes. Tokenization is a process that allows you to define a token to represent sensitive piece of information. A token must be meaningless on its own. Encryption is a way of transforming content in a manner that makes it unreadable without a secret key. And that secret key is necessary to decrypt the content. Protecting the data at rest. The data at rest represents anything that's stationary, that is persistent for any duration of time. And the examples are block storage, object storage, databases, archives, or any other storage medium on which data is persistent. Protecting your data at rest will reduce the risk of unauthorized access. And this can be done with the help of S3, which is an object storage that integrates very well with KMS, like we saw in the lab yesterday. EBS is also a block storage, which can be integrated with KMS again. So you can perform block level encryption with your operating system tools or third-party solutions. Protecting the data in transit. The data in transit is any data that gets transmitted from one system to another. And that includes communication between resources within your environment as well as communication between other resources and end users. Now, we do that with HTTPS using TLS as a common best practice in the world today. You manage your certificates with AWS Certificate Manager called as ACM. You can also leverage VPN connectivity into your VPC or across your VPCs to facilitate encryption of traffic. Data backup, recovery, and replication. By defining your backup, replication, and recovery approach, you help protect against deletion or destruction of data. A very sound approach for data backup and replication will help you protect you in case of a disaster. Properly secure and protect your primary and secondary data sources. AWS provides you with multiple features for data backup and replication. For example, S3 for 99 and 11.9 for durability of objects. You can create copies of the content that can be replicated to other locations. It's a great way to quickly restore the content from S3 bucket. If you're using relational databases, you can use snapshots of your databases. Snapshots are taken on EBS volumes and they can be copied across AWS regions if required for availability. You can also automate tasks and schedule jobs to perform backups and restores. Consider using a Lambda function to issue backups at an interval using CloudWatch events. Not to forget, Glacier is secure, durable, and extremely low cost cloud storage for data archiving and long-term backup. When defining your backup, replication, recovery approach, ensure you review the scenarios under which you want to be protected, as well as the nuances for each setup. Make use of S3 cross-region replication. Make use of S3 life cycle policies and versioning. Also make use of EBS snapshot operations that will let you back up your volumes attached to your EC2 instances. What's the conclusion? Regardless of what we may have and how many layers of defense you keep in your infrastructure, security is never done. Security is an ongoing effort. And when incidents occur, they should be treated as opportunities to improve, opportunities to manage your well-classified data. Having a strong authentication and authorization controls, having automatic responses to security events, having protection to your infrastructure at multiple levels. It is something that every business needs as on today. And I read it somewhere that information is the oil of the 21st century. Like how oil was when it was introduced to the world. Everybody wanted oil, even today. But somewhere today information falls on the top category of what people want. And as security engineers, we guard it with various controls and techniques. AWS strives to help you and us build and operate architectures that protect your information, systems, and assets while delivering business value. So we'll use tools and techniques that we just discussed in this pillar to protect your infrastructure from evil eyes. Any questions so far? These are certain general design principles. We don't have to guess your capacity needs like the way we used to do it in premise, because now we have vertical scaling and horizontal scaling as the buzzwords we can use to scale as and when we need it and scale when the application needs it. Automate your architecture to make those experimentations easier, because now we got cloud formation that will help you build the infrastructure quickly. Data driven architectures. So based on the data, that is based on the CPU load or the memory load, the infrastructure should be intelligent enough to scale up and down and detect the load on the infrastructure. Allow for evolutionary architectures, use serverless designs as and when it's needed, design for failure, and design for security. Always design for availability, make sure that we have highly available infrastructures and highly secure infrastructures. But again, like I said in the previous slide, regardless of how much we do, it's never enough because it's always an ongoing effort and always a constant learning. I will pause for a moment for you to read those questions as to what questions you must ask yourself and the business before you start deploying something. Please read. Okay, heading on the next set of questions. So this was the first step. This is the second one. Okay, a few more questions there. All right, moving on. This is too many questions. Okay, another set of questions there. Okay. Any questions for me? Or if you'd like me to flip back to any of the previous slides, please do let me know.
Are those questions similar to what would be on the exam?
No. There would be, I mean, you won't have questions directly like this, but the scenarios that will be presented to you will be mapping to one or more questions together. So if you have a mindset of answering these questions appropriately, and if you can map a tool to some of these questions. For example, how are you backing up your data? Well, as soon as you look at a question, we must have either a tool or a process in our mind. Now, AWS is more focused on the tools which AWS provides. So I'll look at S3, and within S3, the storage classes that it has, and Glacier, retrieving, etc. So we don't have to memorize the SLAs and durability of S3 and Glacier, but we should at least know that if I need to take an EBS snapshot, it's going and sitting in S3 in the form of incremental storage, and Glacier is used for long-term archival purposes. So if you know when to use a storage class like S3 standard or infrequent access or reduced redundancy, when should I use each of those services? That should be fair. What kind of encryption methodology should I use? Where am I keeping the keys? What does HSM stand for, like the hardware security module? So as long as you know what service is helping me in a particular situation, or when you've been thrown at a particular situation, what tool will you use to get out of that is what the exam is looking at. And all of these questions are actually pointing us to the services that AWS has. For example, let's look at the second one. How are you doing configuration management of your workload? Is the AWS config is a tool. How do you monitor your workload to ensure it's operating as expected? Well, I use CloudFormation. CloudWatch. I'll use S3 to put all my logs inside the S3 bucket, and then also monitor the activities in IAM with CloudTrail. These are pretty basic things there. We should just be able to answer these questions and map a particular tool with these questions. That's what exam wants you to know. And most of these are scenario based and not straight off questions like this.
Okay.
Okay. Okay. Let's so should we just walk around, take a quick 5-minute break or something, and then we come back?
Sounds good.
Okay. There you go. We just passed through 20 slides. This was pretty big, and then we got another 30 slides to go, and we got an hour and a half. Probably we're on track, maybe. Let's see. Thank you. Let's regroup in like 10 minutes. Thank you. Let's get started with the next pillar of the well-architected framework, which is the reliability pillar. What is reliability? It is the ability of a system to recover from infrastructure or service disruptions dynamically. And it must be dynamically able to acquire computing resources to meet demand and also mitigate disruptions such as misconfigurations or NA network issues. This reliability paper, I'm just trying to flip to the next slide. Yeah. So here we discuss about the various components as to how you can increase the reliability of your infrastructure. Starting with the first one, which is testing the recovery procedures. In an on-prem environment, testing is often conducted to prove the system works in a particular scenario. Testing is not typically used to validate recovery strategies. In the cloud, you can test how your system fails, and you can validate your recovery procedures. You can use automation to simulate different failures or to recreate scenarios that led to failures before. This will expose the failure pathways that you can test and fix even before a real failure scenario occurs, and thereby you will be reducing the risk of components that have not been tested before failing. You can also automatically recover from failure
by having a monitoring system in place for key performance indicators, also called as KPIs. So you can trigger automation when a threshold is breached. These KPIs should be a measure of business value, not of the technical aspects of the operation of service. You can also scale horizontally to increase aggregate system availability time. You can replace one large resource with multiple small resources to reduce the impact of single point of failure on the overall system. Distribute your requests across multiple and smaller resources to ensure that they do not share a common point of failure. And always stop guessing the capacity. A common cause of failure in on-premise system is resource saturation. That is when the demands placed on the system exceed the capacity of that of a system, which will lead to denial of service attacks. In the cloud, you can monitor demand and system utilization and automate the addition or removal of resources to maintain the optimum level to satisfy demand without over or under provisioning. You need to manage change using automation. Changes to your infrastructure should be done via automation, and these changes that needs to be managed are changes to the automation. What is the composition of reliability? So we are focusing on service availability. Service availability is the percentage of time your system, your application, or your array of applications are up and running. The main foundation of your infrastructure is the networking. So when architecting systems using IP address based networks, you need to plan the network topology and addressing in anticipation of future growth, and then integrate with other systems and networks. You might also want to find out your infrastructure, how it is limited, and if you have any plans for growth, and if you might have difficulties integrating incompatible addressing structures. VPC is there to provision a private, isolated AWS cloud where you can launch AWS resources in a virtual network with your classes of IP addresses that can be defined using RFC 1918, which allows the IP address space for multiple VPCs per region. You can then have the change management in place and also failure management. So whenever there are changes in the infrastructure, they must be logged using a well-known change management tool. I think most of the people, organizations today use ServiceNow, but then there's a lot of others like HP Remedy, uh, CA, Unicenter Service Desk, things like that. So we'll have change management and failure management logged appropriately. There's this concept of limit management. We did speak about that you will have limits for every resource. So when architecting systems, there are physical limits and resource constraints that needs to be taken into account. A common source of failure and a reason for lack of availability is a resource constraint. For example, the rate that you can push bits down a fiber optics cable or the amount of storage on a physical disk is a limit. So understanding those physical constraints is the first part of designing a reliable system. You also need to plan your network topology accordingly. What kind of infrastructure are we looking for? Is it hub and spoke, or bus topology, how you will have a VPC to VPC peering done. Do we need that? Do we really need a direct connect? And if yes, to how many data centers on your premise are you doing a direct connect? That's part of the network topology section. Certain examples of limit management is the list right here. The number of EC2 instances in an auto-scaling group, provisioned input-output operations per second, relational database service storage that is allocated, EBS volume allocations, network input-output, the total number of IP addresses in a subnet or a virtual or a VPC is also a constraint there. And AWS gives us certain service offerings that will help us manage our limits. AWS Trusted Advisor is one of them. And Trusted Advisor can also give you a report in the form of an Excel sheet that tells you that the number of VPCs that you have exceeded. You're about to reach that exhaustion limit, the throttle limit, or the total number of keys that you can create for a user you have reached. And you can also get an alert triggered using CloudWatch and then email sent to you using SNS. CloudWatch logs will give you a metric filter that can be used to search and extract patterns in a log event. Log entries are converted to numeric metrics and alarms can then be applied. So yeah, Trusted Advisor, CloudWatch, and CloudWatch logs are certain key areas. Planning network topology. How many VPCs do you envision you will be using? Will you be using VPC peering? Will you be connecting your VPNs to any of the VPCs? Are you going to use direct connect or internet? How about using VPN connectors or multiple VPN connectors for failover? Yesterday we did speak about this failover section where organizations use not only direct connect but a combination of direct connect with another direct connect or direct connect with another VPN. RFC 1918 is nothing but class A, class B, class C, D, and E. That falls under RFC 1918. We spoke about change management a little bit. This is really important to eliminate any unprecedented impacts on your infrastructure. So this is part of the ITSM and NA service oriented architectures. We must have detailed logs of NA changes in demand, monitor them, and a change execution plan with a backout plan. There are also on-demand changes that happen based on the resource utilization. So whenever it's also called as demand management. When CPU crosses certain threshold, you will have new resources created. That's kind of horizontal scaling. Elastic Beanstalk also has such options which you saw today. You can configure them under the configuration section. Monitoring is done with CloudWatch. The logs are generated. Log aggregation is done in S3. And thereafter, there are organizations that will export those logs from the S3 bucket to on-premise aggregation mechanisms like Splunk. There's storage and analytics that can be done. Storage of the logs is done on S3 and analytics can be done with Kinesis and EMR. So logs are generated from various places. And the list that you see is just a log generation, not the utilities, but the locations from where the logs are generated. So oh my god, that was scary. Monitoring at AWS consists of different phases here. So we are talking about different phases of monitoring, like generation of logs, aggregation of logs, real-time processing and alarming, storage, and analytics. So talking first about generation, first determine which services or applications require monitoring. The list that we see here, like container services, load balancer, EMR, auto scaling, CloudWatch, VPC logs, all of these are places from where logs are triggered, and from here we aggregate them, put them together. S3 usually acts as an aggregation point. It's a primary aggregation point of all storage layers. For example, autoscaling and ELB. The default metrics are provided out of the box for CPU load or average request latency across a cluster of resources. The VPC flow logs are sitting inside S3. CloudTrail is sitting inside S3. CloudWatch logs after 90 days will go and sit in S3. Thereafter, you will do real-time processing. Alerts can be triggered, auto-scaling events, so that any changes in demand can be seen on a board or something. A graphical representation can be done. Alerts can also be sent via SNS, which is simple notification services, and they can be pushed to NA subscribers. Then storage analytics. CloudWatch logs also support subscriptions that allow data to flow seamlessly to Amazon S3. As CloudWatch logs and other access logs arrive in S3, you should consider using EMR to gain further insight and value from the data itself. If your data is written in a supported manner, S3 can be used to query the data. There are third-party tools that are being referred here. The number of tools provided by the Amazon partners and third parties that can be used for aggregation, processing, storage, and analytics. Some of these tools are New Relic, Splunk, Logly, Logstash, Cloud, Health, and Nagios. However, generation outside of the system and application log is unique to each cloud provider and often unique to each service as well. Conclusion for reliability. Just like security, reliability is an ongoing effort. It doesn't end. We always need to monitor for changes, and any new incidents that have been brought up need to be taken as an opportunity to understand and improvise on the architecture. Regular tests of failures and backups must be done. Catch those errors even before they reach production, and if the error occurs in production, well-tested architectures will mitigate those failures. So it's always encouraged to take advantage of the design, operational, and service recovery oriented recommendations offered in this reliability pillar document. The next pillar is the performance efficiency design principles. So before we go there, I would like to ask if the team has any questions. We spoke about reliability pillar and the security pillar. We've got 3 more left. Before we go with the performance one, I just want to take a step back and circle around the mic to the team to understand if the team has any thoughts, any questions, anything people want to share. Okay. The third pillar in the AWS well-architected framework is performance efficiency. The performance efficiency pillar focuses on the efficient use of computing resources to meet requirements and how to maintain that efficiency as demand changes and technologies evolve. In this pillar, we will focus on the best practices guidance for architecting for performance efficiency in AWS. The first point is democratize advanced technologies. Technologies that are difficult to implement can become easier to consume by pushing that knowledge and complexity into the cloud vendor's domain. Rather than having your team learn how to host and run a new technology, they can simply consume it as a service. So why not we take that as software as a service or platform as a service? For example, NoSQL, databases, media transcoding, machine learning. These are all technologies that require expertise that is not even not evenly dispersed across the technical community. And in the cloud, these technologies become services that your team can consume. So this lets your team focus on product development rather than resource provisioning and management. The second point is going global in minutes. Easily deploy your system in multiple AWS regions around the world with just a few clicks. And that allows you to provide lower latency and a better experience for your customers at a minimal cost. Now, we did speak about the third point using serverless architectures. In the cloud, serverless architectures remove the need for you to run and maintain servers to carry out traditional compute activities. For example, storage services can act as static websites, remove the need for web servers, and event services that can host your code for you. And this will remove the operational burden of managing the servers and can also lower the transaction costs because these managed services operate at cloud scale. The fourth point, which is experimenting more often with virtual and automable resources, you can quickly carry comparative testing using different types of instances, different types of storage and configurations. There's a whole lot of permutation combination of resources that can be provisioned and deprovisioned in a matter of minutes at your fingertips. And that will lead to a great experimentation of the application before it goes to the production. Mechanical sympathy. So you use the technology approach that aligns best to what you are trying to achieve. For example, consider data access patterns when you select database or storage approaches. So we're looking at the patterns of the activity at the network, database, and storage levels. Performance efficiency in the cloud is comprised of 4 areas: selection, review, monitoring, and trade-offs. Let's understand them one by one. The optimal solution for a particular system will vary based on the kind of workload you have and often combines multiple approaches. A well-architected system uses multiple solutions and enables different features to improve the performance. With AWS, resources are virtualized and are available in a number of different types and configurations. And that makes it easier to find an approach that closely aligns with your needs. You can also find options that are not easily achievable in an on-premise world. You can look at AWS solutions architects, rely on reference architectures, talk to AWS partners to help you choose kind of architecture that you want. So you can select based on compute, storage, databases. So you have a plethora of options to choose from when it comes to the selection criteria of your resource. In the compute section, you have different instance families. At the click of your button, you can select a machine which can process your graphics, which has a lot of GPUs, lot of burstable instance families, like they're carrying a lot of CPUs. The earlier ones, they had a lot of GPUs, and the other ones that can do high performance computing in a matter of seconds. And if you don't like compute, you can just go and switch over to a container based model or functions like Lambda or serverless architecture designs using AWS container services. In storage section, again, you got a lot of options. You can select based on block storage or file system or object level. So what kind of characteristics in the storage are you looking for? When you select a storage solution, you should consider the different characteristics that you need, such as the ability to share, ability to mount, the file size, the cache size, latency, throughput, persistence of data, and then match these requirements you want to the AWS service that best fits your needs. And there are a lot of storage mechanisms we have today, like S3, EBS, EFS, and the EC2 instant store. So performance is measured by looking at throughput, IOPS, and latency. In database section, again, you got several options like availability of database, consistency, latency, durability, scalability, and the query capability of your database. The optimal database solution for a particular system can vary based on your requirements, like these. And many systems use different database solutions for different systems and enable different features to improve the performance. Here are the options that we have in AWS. There are, of course, more than these today. This slide was made a long time ago, but today we got more than what you see on the screen. There are AWS Neptune as well. There's Elastic Cache, Redis Cache, Memcache, Redshift, and DynamoDB. The new features, lots of new features being introduced. Then we also need to look at the networking aspects in the selection criteria. Do you want your network to be virtualized? Where are your users located? Where is your data located? The optimal network solution for particular system will vary based on latency, based on throughput requirements. And there are certain physical constraints as well, like users location, data location. In AWS, networking is virtualized and is available in a number of options. CloudFront, VPC endpoints, Route 53, Direct Connect, VPNs, and there's just too many of these options which AWS has, and we must know when to use a service offering and a feature. There are other constraints that we need to take an account into, such as security and compliance. Edge locations. Edge locations provide services for caching your content, and by having these services at the edge, they can respond with low latency to request for content or DNS name resolution. The network services like this we just listed a minute ago. And finally, concluding the performance efficiency pillar. Achieving and maintaining performance efficiency requires a data-driven approach. So you should actively consider access patterns and trade-offs that will allow you to optimize for higher performance. We'll use a review process based on benchmarks and load tests that will allow you to select the appropriate resource types and configurations. Treating your infrastructure as a code will enable you to rapidly and safely evolve your architecture. You can use your data to make fact-based decisions about your architecture. Put in place a combination of active and passive monitoring that will ensure that the performance of your architecture does not degrade over time. AWS is there. It strives to help you build architectures that have performance efficiency while delivering business value. The next pillar, which is the fourth pillar, is the cost optimization. Before we go ahead, I would like to take any questions that you may have on either of the three pillars that we spoke so far. Cost optimization pillar. Cost optimization is a continuous process of refinement and improvement of a system over its life cycle. For the initial design of your very first proof of concept to the ongoing operation of production workloads, you can adopt the practices that we'll just discuss about in some time. You can definitely adopt these processes to build and operate cost-aware systems that achieve business outcome while minimizing the costs, allowing your business to maximize its return on investment. A cost-optimized system will fully utilize all resources, achieve an outcome at the lowest possible price point, and meet your functional requirements. Cost optimization has certain design principles. You need to have cost-effective resources, matching supply with demand, expenditure awareness, and then optimize over time. Just like any other pillar, there are trade-offs to consider. For example, whether to optimize for speed to market or for costs. In some cases, it is best to optimize for speed, going to the market quickly, because I want to ship new features or simply meet a deadline rather than investing in upfront cost optimization. Design decisions are sometimes dedicated by haste rather than data, and the temptation always exists to compensate just in case rather than spend time benchmarking for the most cost optimal deployment. And this might lead to over provisioning or under optimized deployments. That is a reasonable choice when you do lift and shift resources from your on-prem to cloud and then optimize afterwards. Investing is Investing in a cost optimization strategy upfront allows you to realize the economic benefits of the cloud more readily by ensuring a consistent adherence to best practices and avoid necessary over provisioning. Cost effective resources. Using the appropriate services, resources, and configurations for your workloads is the key to the cost saving. In AWS, you got number of options, and these options are listed right there. You do the appropriate provisioning, right sizing, choose the right purchasing options for your EC2s and RDS, like on-demand, spot, or reserved instances, geographic location, managed services, and also optimize the data transfer. When you use managed services, the vendor provisions and manages the underlying resources. Typically, managed services have the attributes that you can set to ensure sufficient capacity is there to meet your needs. You need to set and monitor those attributes so that or your excess capacity is kept to a minimum and performance is maximized for end users. You need to modify those attributes of AWS managed services using the AWS Management Console or AWS APIs or SDKs to align resource needs with changing demand. So you can increase or decrease the number of nodes on EC2 or an EMR or on a Redshift to scale out and scale in. Size it right, use the lowest cost resource first that needs your technical specifications of a specific workload. You can right size iteratively later on by adjusting the size of the resource to optimize the cost. And right sizing activities take into account all the resources of the system and all of these attributes of each of the specifications or each individual resource. There are several purchasing options, like we know. There's on-demand instance, spot instance, reserved instance. And when you use on-demand instance, you pay a flat hourly rate. You have no long-term commitments. In spot instances, I will allow you to spare compute capacity at significantly lower cost as compared to on-demand instances, and you get about good 90% discounts there in spot instances, but it's valid only for 6 hours from the first 1 hour to the 6th hour. In the reserved instances, you commit to Amazon for 1 to 3 years. So that way you will cut down on your cost by about 75%. So when your reserved instances are assigned to a specific availability zone, they also provide you with capacity reservation so that you can launch the number of instances you need when you need them.
When do you actually see spot instances used?
Auto-scaling. You'll use spot instances for auto-scaling, specifically for e-commerce applications. When there is a sale period, let's say from 7 o'clock to 11 o'clock, there's a sale period. And when new instances spin up, I don't want to pay for the on-demand pricing because it's about $1 per hour. So I'll go and check that box which says spot instances and bid for my own number. And I'm really happy with 6 hours because my sale is not for 6 hours and I will be done with my job in less than that time.
But you have to select that and you bid on it. How quickly does Amazon come back with a confirmation?
So it depends on certain duration. So if it's real busy hours, for example, on Thanksgiving days and Christmas time, a lot of applications will be using Amazon data centers So if Amazon has capacity, if Amazon has data in that availability zone or racks available in that availability zone, they give it to you. Otherwise, it just flips back to on demand. You will get an instance regardless. Auto scaling will happen regardless, but spot instances will happen if Amazon has resources in that data center. They say that, but Amazon data centers are massive, and they say it's as close to 11 to 12 football fields. And I really don't know for what reason they may not have space in that large area, um, considering that it's all based on usage and on demand. Even in the forums and various places, I haven't seen spot instances failing, but Amazon still has that tagline in the document. They say, hey, if we have space, we give it to you. But based on my readings and forums, I haven't seen it being failing. So that's immediate. The instances are spinned up immediately if we choose spot instances.
All right. Thank you.
Yeah, thank you. Welcome. Okay, so let me go for a full screen. Spot instances, and then reservation. We spoke about reservation as well. So within the reservation, you got two kinds again: standard and convertible. Standard instances provide a billing benefit and a capacity reservation when the instance family, size, availability zone are specified. Convertible reserved instances are provided for an a year or 3-year term and allows you to convert different families of the instances. Like you can move from M3 large to R3 or something. Then you'll get a new pricing from there on. You can choose different instances, compute families, different platforms, or even tenancy during that period. A regional benefit provides billing benefits for both standard and convertible reserved instances. When you specify the instance family and size, you also get multiple options for payment. You really do not have to pay upfront the whole money, but if you pay for the entire amount, you get a massive discount. But there are other options as well. You can choose not to pay any upfront or pay that upfront money partially. So there are three options. There's no upfront payment, partial upfront payment, and full upfront payment. Going to the fourth point, which is geographic location. Latency or reducing the latency is a key factor in improving usage of your e-commerce or other websites. And when you architect your solutions, a best practice is to seek to a place computing resources are closer to users to provide lower latency and strong data sovereignty as well. For global audiences, you might need to use multiple locations to meet those needs. In addition to that, you might also want to choose a CDN, a content delivery network, to cache the content. Use managed services to remove the burden of heavy lifting required to maintain a service. It will allow you to focus on innovating rather than keeping the lights on. By using these managed services, you can reduce or remove much of your administrative and operational overhead, freeing you to work on value-added activities. The managed services operate at a much lower cost per transaction services. And AWS provides managed services in the form of RDS, DynamoDB, Lambda, simple notification services, simple email services, simple queuing services. Expenditure awareness. So usage and usage of resources, understanding your business cost drivers is critical to managing your business expenditure effectively and identifying cost reduction opportunities. Businesses typically operate multiple systems run by multiple teams, and these teams can be in different business units. The key factors to consider when we would like to generate data, analyze, and then report on the costs are stakeholders, visibility and governance, cost attribution, tagging, and entity lifecycle tracking. Stakeholders are mostly financial, CFOs and financial controllers. They must understand the cloud model of consumption, purchasing options, the monthly billing process, accompanying data with AWS cost and usage report. Because there are fundamental differences between the cloud and the way on-premise operation works, it is essential that the financial team understands how this new variable IT model can impact aspects to the business, such as procurement processes, incentive tracking, and financial statements. Tech leads must translate external business usage or cost factors from the financial and management stakeholders into system attributes or adjustments. Visibility and governance controls. So you estimate and forecast your AWS cost and usage, receive notifications when you exceed your budgeted thresholds, assess your biggest investments in AWS, analyze your spend and usage data, get a report of the reserved instance utilization and reserved instance coverage report, which is available in the billing section in your subscription. Cost attribution. You can use cost attribution to drive cost management by assigning costs to systems, revenue streams, or parts of your organization, such as departments, business units, internal teams, etc. Tagging. Tagging allows you to overlay businesses and organization information into your billing and usage data. That will help you categorize and track your costs by meaningful, relevant business information. And you can apply tags that represent business categories such as cost centers, application names, projects, or owners. That will help you organize your costs across multiple services, teams, and subscriptions. When you apply tags to your AWS services like EC2s or S3 buckets and activate the tags, AWS adds this information to the cost and usage reports. So assigning tags to resources allows higher level of automation and ease of management. So you can execute management tasks at scale by listing resources with specific tasks and then executing the appropriate actions. Entity lifecycle tracking. When you manage a life of a project, when you manage a list of projects, employees also manage the list of technology resources over a period of time. You will be able to identify resources that are no longer being used or orphaned objects that no longer have an owner. So AWS provides a number of services that can can be used for entity lifecycle tracking, such as AWS Config, which provides a detailed inventory of your AWS resources and configuration and continuously record and configure changes. CloudTrail is one such example. CloudWatch will allow you to establish a record of resource lifecycle events. Identity and access management allows you to manage groups, users, roles. Concluding the cost optimization segment or pillar of the well-architected framework, just like every other pillar, cost optimization is an ongoing effort. From the first review of a pilot or a test workload to deploying a mature production infrastructure on AWS, you should regularly review your architectural approach and component selection. And this effort is made easier and thanks to programmatic functions and AWS features and services like CloudFormation. AWS strives to help you minimize the costs, help you build resilient, responsive, and adaptive deployments. The next section is operational excellence, and this is the last pillar in the AWS well-architected framework. Before we start with this next pillar, I want to pause for a minute to understand if you have any questions, any discussions that you would like to bring to this table so we can learn from each other. Would you like a break or something? Because we're almost done. We got 30 minutes with us, so you just walk around and get your coffee if you like. What do you think?
Sure.
Thank you.
5 minutes?
5 minutes. Great. Yeah.
All right. Thank you.
Thank you. Welcome back, everybody. Let's get started with the next pillar and the last pillar of the AWS well-architected framework, which is the operational excellence. Along with other pillars, this also has a great weightage, and it's important to understand all of these pillars from the exam perspective. What are the design principles, specifically as far as operational excellence is concerned? Managing and automatic changes, responding to events, defining standards to successfully manage daily operations. For operational excellence, it includes the ability to run systems and gain insight into the operations, and that will help us deliver business value and to continuously improve supporting processes and procedures. There are design principles for operational excellence in the cloud, and one of them is to automate and perform operations as a code. In the cloud, you can apply the same engineering discipline that you use for applications code to your entire environment. You can define your entire workload like applications, infrastructure as a code and update it with the code. You can script your operations procedures and automate their execution by triggering them in response to events. By performing operations as a code, you limit human error and enable consistent responses to the events. In an on-premise environment, documentation is created by hand, used by humans, and they're hard to keep in sync with the pace of change. In the cloud, you can automate the creation of documentation after every build, and this documentation can be used by humans and systems. That is called as annotations. These annotations can be used as an input to your operations code. We make frequent, small, reversible changes in the form of a code. You design workloads to allow components to be updated regularly to increase the flow of beneficial changes into your workload. Make changes in small increments that can be reversed if they fail to aid in identification and resolution of issues introduced in your environment. You refine operations procedures very frequently. And as you use operations procedures, look for opportunities to improve them. And as we evolve your procedures appropriately, set up a regular game days to review and validate that all procedures are effective and that teams are familiar with them. Anticipate failure. Perform a post-mortem and a pre-mortem exercise to identify potential sources of failure so they can be removed or mitigated. Test your failure scenarios and validate your understanding of their impact. You will have operational excellence if you prepare, operate, and evolve. These are the three steps or three areas of operational excellence: prepare, operate, and evolve. You prepare for operational priorities, prepare for designing of operations, and readiness. And to conclude this, operational excellence is also an ongoing effort. Every operational event and failure should be treated as an opportunity to improve the operations of your architecture. You need to understand the needs of your workloads, predefine the runbooks for routine activities, playbooks to guide issue resolution. Through focusing on incremental improvement based on operational priorities and lessons learned from event response and retrospective analysis, you will enable the success of your business, thereby increasing the efficiency and effectiveness of your operations. AWS is constantly striving to help you build and operate architectures that maximize efficiency while you build highly responsive and adaptive deployments. To make your workloads truly operationally excellent, follow the best practices. With that, we conclude the well-architected framework or the pillars that are defined in the well-architected framework. I open up this forum now for any questions, discussions you may want to bring to the table.